This is a classic question of the chain rule. So we've got this weird thing here that says y is equal to g, right? And then it's got a bracket and then an f and then an x. And like, what does that all mean? Basically, what we say is y, first of all, starts off being equal to g of x. What is that? Well, let's grab it from over here, right? That's that guy here. That's like saying ln of x, okay? All right? But instead of the x, we're going to substitute in what f of x is equal to, and that's this guy over here, that's over here in the pink, and that's that 2x plus 5. So wherever we see an x, we're going to put instead a 2x and then plus a 5. So do you see that x over there? We're going to replace that with a 2x and then plus a 5. So what this equation really equals to, right? What this equation really equals to is this. Y is equal to ln 2x plus 5. Okay? And so we need to do this without a calculator. The chain rule, you may have seen this kind of, I guess, equation before, that dy dx is equal to dy du times by du dx. Okay? In this case, it would be like we just differentiated this bit, that ln x, and that's this dy du. And then we go ahead and we differentiate du dx. So let's just find a substitution here, right? Let's just say that u is equal to, right, f of x. And that means that it's equal to 2x plus 5. All right? So that's what we can say. It's equal to 2x plus 5. And then we can say that du dx, just differentiate this 2x plus 5, and that's equal to just 2. All right? Because the x is to the power of 1, so that multiplies across, and we minus that 1, and then the 5 is x to the power of 0, so that 0 comes down and just like deletes that. So now we're left off with just 2. That's really important. I'm going to color this a different color so we know what's going on here. But now we need this dy du. So what we can say is that y is equal to ln u. So when we find dy du, that is equal to 1 divided by u, because that's the whole shtick about differentiating the natural logarithm. It is, right? So now if you have another value in here, like let's say a 2, we can say finally that our dy dx is equal to, let's say this thing in blue here, 1 divided by u, times by, all right, 2. But now we need to substitute in that u is equal to 2x plus 5. So we need to just sub u is equal to 2x plus 5 back into our equation. Okay, and there we go. We can get it back to say 2 all divided by 2x plus 5. All right, that's almost the question done. But it says, and hence find the gradient of the function, right? Hence find the gradient of the function at x is equal to 2. So now what we do is we can say y tick, that's the same as saying dy dx, right? So we can say y tick at point 2 is actually equal to 2. Just substitute that in wherever you see an x, right? You like pick this up and you put it in replacement of that. So I just remember like it used to be like of x, but like it used to be y dash of x, but wherever you see that x, just replace it with that 2, and that makes life a lot easier. And then we're just going to go ahead and simplify everything here. Okay. Um, so we're just um, gonna go ahead and simplify it, and life becomes a little bit easier to say that it's 2. 2 times by 2 is 4, plus 5, which is equal to 2 divided by 9, and that is our final answer. Okay, that is our final answer. There we go. Okay, so hopefully that makes sense, the whole chain rule thing. But eventually, when you get good at it, you don't even need to explicitly write it, right? Like, you'll just know that ln of 2x plus 5, you'd be like, ah, yes, I know that's just equal to all divided by, keep the stuff that's original there, that 2x plus 5, and then we just need to multiply by that 2, right? And there we go. Like, life becomes like a lot easier. So you don't need to explicitly go through all the rules. But while you're learning, really important to do so. Now, I've got heaps of questions like this on my website. You can find them there. They're more likely to appear in your test than some of the questions you're working hard on now in your textbook. So have a look at them. They're more likely to appear in the exam and test, so you're more likely to get marks. If you still struggle, right, reach out to me. I offer tutoring services online or in person, and group as well. So would be happy to help. Otherwise, leave a comment. I'll also love to get back to you there.